Okay, today we're going to do the derivation for an inverting op amp. I can't spell amp, just bear with me here. So, in an inverting op amp, our voltage input occurs on the inverting input right there, the negative sign. So how do we solve this? It's a little different than the non-inverting op amp where we did voltage division. Over here we got to use a little bit of current rule. So we know that the current going inside of the op amp is ideally 0. So if we say this is I1, this is I2, in the ideal case, if these are 0, then I1 is equivalent to I2. Great. So let's find I1 and I2. So we know that from here, Vn is equal to I1 times R1. For I2, we know that Vout is equal to I2 times R2. Okay. So that if we know that both of these are equivalent, and this is actually, this is entering, this is exiting, so I1 is equal to minus I2, right? In that case, we could do some substitutions here, okay? We can do Vout over R2 is equal to minus I2, which is equal to I1. We can insert it right here. We could say that Vn is equal to minus Vout over R2 times R1. We could do some division. We could say that Vn over Vout is equal to minus R1 over R2. We flip this. We could say Vo over Vn is equal to negative R2 over R1. Now, this negative is essentially, I shouldn't have written a negative I2 right here, it should be I2. If it's just I2, we can set this to equal negative. And then we can insert this into this, which makes this true, which makes this true, okay? And since this is true, we know that this is AV and this is negative, so it is an inverting op amp. Because whatever input voltage you give it, it's negative, it will be positive. If it's positive, this will be negative. Capiche? Great. Now, one thing to notice is the concept of feedback. If our voltage right here goes up, what happens? The voltage here goes up. But since this is the inverting input, the output voltage will be going down, right? So if this goes up, this goes down. That is the concept of feedback. Great.